Hyderabad, Telangana from 2006 to 2020. Previously, he has worked as a senior project officer at Speech and Vision Laboratory, IIT Madras. He has worked as a member of faculty at BIT Davangere, Karnataka from 1991 to 1999. He has also worked as a visiting research scholar at OJ Portland, USA for 3 months during the summer of 2001. He has done his postdoctoral studies PDF at Carnegie Mellon University, CMU, Pittsburgh, PA, USA during April 2007 to July 2008. He is the author of about 150 papers published in national as well as international journals, conferences, and edited volumes. He is a life member of the CSI, IE, IUPR, AI, ASI, IETE, ORSI, and ISTE. He has reviewed papers for reputed journals and conferences. His research interests include speech processing, neural networks, machine learning, natural language processing, artificial intelligence. He was local organizing chair for the Interspeech 2018 conference, which has happened in India in September 2018, held at Hyderabad. With this, I would like to welcome Dr. Suryakanth V Gangashetty.
Good morning, everybody. Thank you very much, madam, for the kind introduction. I think this previous 2 days you might have heard many aspects of speech signal processing from the eminent speakers. Today I am going to deal with something called epoch-based analysis of speech signals. Let us see what is this analysis. And as you know that speech signal, it is produced from the speaker, and listener will be listening here. The way in which manner speech signal is produced is that when a speaker wanted to say something at the talker side, initially he will think what is to be spoken. That is called message formulation. Once it is decided what is to be spoken, then we will think of in which language it is to be spoken. Based upon that, what is to be spoken, in which language it is to be spoken, based upon that set of nerve signals are generated and transmitted to the vocal tract or mouth. And again, what you are going to speak, based upon that your vocal tract various components will be articulated. Finally, you will get as a what you call a speak signal in the air, that is the acoustic signal. It reaches to the ear of the listener and it reaches back to the ear of the speaker itself, but it is intended for listener. Therefore, even we hear our own speech will not that much bother, because it is not to ourselves. When we are speaking, it is to somebody. Okay, then having said that, now when you have the signal, it is at the acoustic level. You can say acoustic pressure variation at a particular point of time in front of the speaker, that is the speech signal. When you see the speech signal, it has information about the linguistic at the linguistic level, because speech signal is associated with the language. At the physiological level, vocal organs are articulated, and this information is implicitly embedded in the speech signal which is coming out of the speaker. When it is coming out of the speaker, similar phenomena takes place in the reverse order at the listener side. What it means is the following: when the speech signal falls on the when a speech signal falls on the ear of the listener, initially baseline membrane motion vibration takes place, then neural transduction, then language translation, finally message understanding takes place. This is the way speech is produced and perceived. Now coming to the say in detail how human this one is like speech perception mechanism works. Yeah. Now speech production mechanism. You might have seen this slide. So the way speech produced in the mechanism itself is we during normal respiration air enters into the lungs through nose, and when sufficient air pressure built below this, there is a point called vocal folds. This is very very important to us for our current study, today's study. And see, when sufficient air pressure built below this, then this opens. When this opens, air comes out. When air comes out, then there is no pressure, then it closes. When it closes, again after some time, this tube will be trachea or tube will be filled up with the air. Because of the air pressure, it opens. When it opens, air may comes through mouth or through nose, depends upon the kind of sound we are producing. And this vocal folds, if you see, touch here somewhere, this vocal fold are called or sometimes called vocal cords. The vibration of that takes place 200 times at least in male speakers, and two times more, that is about 300 to 400 times in women, because this the tissue, cells, blood, flesh associated with this vocal fold, the composition matters. If they are more delicate, vibration of that will be more, and this vibrates says number of times. And for this vocal fold, vibration is important for us for the today discussion. In what way it is important is that, see, when these vocal folds are closed, the see opening is slow, closing is all of a sudden abruptly it hits. When it hits, then this vocal tract and this vocal below this vocal fold or vocal what you call glottis, they are disconnected. This glottis is below this, just see, this is the glottis, this is the below glottis, and this is the above epiglottis. And now when they are disconnected, th- this vocal tract is called system, and below is called source. Source is just puff of airs, it is coming out. Vocal fold act as a source, and vocal tract act as a system. When see, normally this both system and the source are interconnected, where when they are, since they are interconnected, and when vocal there is no vocal fold vibration, then vocal folds are totally closed, then air will not come out. In that case, system functions independent of the source. And this vocal fold vibration, what it gives is, it is a speaker characteristic. It is the characteristic of the speaker, whereas vocal tract is the characteristics of this sound. Depends upon the kind of sound we wanted to produce, we will be having what you call them, the size and shape of that changes. And vocal folds characteristics are unique to the speaker. Even by just by when you assume that electroglottograph EGG, if I keep EGG just on the vocal folds and record, when you process that, you can get the speaker characteristics. Now, with this background, we are going to, yeah, I will now share one more thing, one more. one, yeah, ELS, fluent. See some paper on the screen, right?
Yes, sir.
Yeah,
Yes, sir.
Epoch is analysis of speech signal. Okay. Now see, our now discussion is fully depends upon this paper. That is, this paper we have published in 2011 in Sadhana, and it is a very good, like 651 to 697. There are about 47 pages are there. Um, this will be my, you call, reference for this entire talk. Now, coming to see what I am telling here is that, let us say when you record the speech signal, putting some transducer on the vocal fold, what happens is, based upon the time, horizontal axis is time, vertical axis is impedance. See this, whatever we call A, or whatever, say I am labeling here, this is 1, this is 2, this is 3, this is 4. What I am showing is that this is a EGG signal for the segment of voice or speech taken from a continuous utterance for four distinct phases of a glottal cycle. Once say, in order to like say I told 200 times it vibrates. That means there are about 200 cycles. For every cycle, way it happens is that, so this is a glottal cycle. In the EGG signal, we can identify this is called closing phase. This much time, say 1, that the closing phase. 2 is called closed phase with maximum contact, and this corresponds to 3 corresponds to opening phase, and 4th corresponds to open phase. Closing phase, closed phase, opening phase, open phase. See, this much time, total time, maybe for example, when it vibrates 200 times, means for every millisecond, that for every 5 millisecond, that is 5 millisecond is the cycle period, one period of the glottal vibration, closing and opening. It has 4 phases: closing phase, closed phase, opening phase, open phase. With the, when we have these 4 phases, that will all takes place in 5 milliseconds. Now, why is, why are we studying this? Is that when I have, and be switching from one slide to another slide, just for discussion sake. Yeah. See now, when I go back here, what happens is this starts closing, totally closes, opening, starts opening, total opens. So when it closes immediately, that is called glottal closure instant. Glottal closure instant, sometimes it is called epoch. I do not know what is the reason of like calling it as epoch. There is a epoch, and this speech close, vocal tract closing, opening, vocal fold, nowhere related that somebody gave the name as epoch. Anyway, now as that point at which our glottal closure closes, the point at which, see the time at which this vocal fold closes, that is called glottal closure instant, GCI. Sometimes it is called epoch. Why that, we are interested in identifying those epochs in the speech signal is that they are all very important. They are important cues, because at that time vocal tract and vocal folds are totally disconnected. That's why we are interested in what you call glottal closure instance. And normally in speech analysis, what we do is, I think previous speakers have spoken, we do something called short-term Fourier analysis, STFT. And for every say 20 millis, we will take some 20 millisecond speech signal, then like process it. Then we will go for the another 20 millisecond speech signal. In that way, it will we are processing. But there the problem is that that is called block processing. Block processing has some limitations or side effects as speech signal is concerned, because window size come into picture, shape of the window comes into picture, all those things. First, identify the glottal closure instance or epochs and analyze the speech for around that epoch. Then what are all the possible analysis can be done by using this epoch based analysis. Epoch based analysis, see, useful in various aspects. What are all, see, for example, normally what we have done is perform using short term Fourier analysis to extract the features, and we convert speech into Fourier transform. We will take that, then we'll get the frequency domain. And as I said, window size is very much important, but normally we will fix something such as 20 millisecond and so on, frame shift some 10 millisecond, we will move further off again. And mainly to account for the time varying vocal tract system during the production. But what happens is, speech in its primary mode of excitation is produced, it is due to impulse like excitation in each glottal cycle. Because say for every 5 millisecond, vocal fold closes, open. Again it closes after 5 millisecond, that open. Therefore, if we anchor our speech analysis around these glottal closure instances, or GCIs, or epochs, then we do better speech analysis rather than doing block processing. Because see, again, this is not exactly 5 millisecond one cycle, it may be a little bit less, little bit more, but an average it is 5 millisecond. Then you may take, why can't I take 5 millisecond at a time and process? See, my pitch period may be 5 millisecond, somebody's pitch period maybe, for example, if like somebody this one is 100 times, only 100 times it vibrates, then 10 millisecond, that is slower than mine, because time required to close and one like vocal fold is 10 millisecond in some other speaker. In my case it is 5 millisecond. That means my vocal fold vibrates fast, that means my vocal folds are very, what you call, um, um, my vocal folds are like soft of a kind. Okay, then um, see, what happens is epoch based analysis, it helps not only to segment the speech signal based upon the speech production, but also accurate analysis is done. It enables extraction of important acoustic phonetics such as glottal code. Epoch based analysis is very important for accurate processing of the speech. Then where are all it is useful? Because I wanted to know glottal close vibration features. Glottal close vibration itself is a speaker characteristics. Then formants. Each sound unit is associated with three things. Formants are the resonance of the vocal tract system. What is meant by resonance? Resonance is that when I wanted to say a sound unit say then my vocal tract is a tube. That tube changes its size and shape because it is a biological tube, therefore it changes its size and shape. When it changes size and shape, that it becomes one kind of tube, and every tube has something called resonant frequency. Three major shape of the vocal tract takes place to produce a sound. They are the formants. And formants, say three formants collectively describe one sound unit. Say formant one maybe 500, ferment 2 maybe 800, ferment 3 maybe 1300. Say oo, then ferment 1 maybe 400, ferment 2 maybe 900, ferment 3 can be 1100. To extract the estimate the ferments, then instantaneous fundamental frequency, that is vibration of the vocal fold at a particular instant of time, and this these are very much accurately you can estimate when you perform something called epoch based analysis of the speech signal, rather than performing conventional like block processing approach. See, all your signal processing methods, what happens is there are some understandings to be a signal is assumed to be stationary to use all the FT methods, signal processing methods, but speech signal is non-stationary. But still, you wanted to make it as stationary assumption because you wanted to use signal processing methods. Therefore, you are taking a small amount of speech signal at a time to process, like 20 millisecond, 30 millisecond. During that time, speech is assumed to be quasi-stationary. And now, epoch sequence is useful in another something called speech synthesis. That is, in case of like speech synthesis, we do some analysis called prosody manipulation. That is intonation, duration, and pitch of the speaker. There also it will be useful. That is speech synthesis. It is useful, and I will tell where in speech recognition useful all those things. Accurate estimation of the epochs are significant instance in the speech signal. Significant instance of excitation is called epoch. You remember this sentence. Significant instance of excitation. See, we are exciting the vocal tract by hitting with the help of vocal folds. When vocal folds they are delicate, they closes. That closure gives energy to the vocal tract. Therefore, you have that closure for every 5 millisecond. That location we are identifying, then analysis is taking place during that, around that. That's why it is epoch based analysis of speech signal. And this epoch based analysis is useful in finding instantaneous fundamental frequency. That is what is the duration of closure and open, glottal closure cycle, then ferments. And in case of speech synthesis, prosody manipulation, epoch based analysis is useful. Therefore, accurate estimation of the epochs helps in characterizing voice quality. See, there is a concept of voice quality. We will discuss that. In voice quality analysis, also epoch based analysis is useful. And epoch extraction are finding the location of the significant instance of excitation helps in enhancement of the speech, because around the epoch location, speech is assumed to be having high signal to noise ratio, high SNR regions. It is useful for speech enhancement. And assume that I have many speakers in the speech signal speaking. When you record a speech, when many people are speaking, if you wanted to separate the speech, you wanted to hear the speech of a particular person, then you don't want to hear speech of other person. In that case, multi-speaker separation epoch analysis is useful, because my fundamental frequency is different from somebody's fundamental frequency. When two speakers speaks having different fundamental frequency, then identify the epochs, and you can take out the speech of a particular speaker because you know the fundamental frequency. That helps in separating the multi-speakers. Therefore, in this work or in this presentation, what we are doing is importance of epochs for speech analysis, then how to extract the epochs and application of epochs. As I said earlier, this we have seen already. This is one cycle. I am interested in the point where it is labeled as 2, that is closure phase. Again, after open phase, opening phase, open phase, then closing phase, again this is a closure phase. I'm interested in when I have a signal over a period of time, you are interested in this point, this point, this point, and so on. That is the meaning of like again this. What is this EGG signal? Electroglottograph. It's a, we are mounting on the vocal folds and recording. Take for example this. See, first one is the speech signal. Then see, I will ask somebody. See, I have two microphones. One is in front of the mouth. Another one is kept on the vocal folds or glottis. I will record the speech signal. I will record the EGG signal. Then, how to know where the glottal closure occurs or closing of the vocal fold occurs in the speech signal? For example, from here you cannot make out. It is like a it's a quasi stationary and like you cannot make out where glottal closure has occurred. Of course, you can guess in the visceral region. Those are all occur. For example, it is this point, this point, this point. But these are all not that easy to locate in the speech signal because see, this is high in this locality. This is high in this locality. You have all these local maximas, not global maximas. For example, here by visual inspection you can make out this is high, this is high, this is high. But how to automatically detect the location, epoch locations in the speeches, it is a difficult task. Therefore, okay, now how are you finding? Let us say I have the EGG signal. If you difference the UGG signal, then what happens is you are getting these dips. These dips, these are the location of the epochs. You see, this matches. Take for example, this itself, the first one. See now, this is the this dip. Second, this is the dip. This dip. Therefore, from this, if you difference means what? Subtract successive samples. A second sample minus one, third sample minus second sample, fourth sample minus third sample, and so on. These points, minimum, the points where this is difference is the time axis, and wherever this minima is occur, these are the epochs locations in the speech signal. But notice, you will not be recording EGG signal and speech signals simultaneously because when you speak, you may record only what somebody is speaking. You cannot keep some like a microphone, something on the vocal fold near the neck. You ask somebody, it become too artificial. Therefore, this is not available in most of the cases. Whatever available is this. Therefore, how to find the epoch location in this automatically is important. Then let us say in known case I have this as well as this. Assume that I come up with a method which can detect the epochs here, and then what happens is, assume that I come up with a method. I will use this P signal, and if I can find these locations, then I assume that for that P signal there is a reference of EGG also. Then I can validate my method what extent it my method recognize or identify the location. That's something called various methods for identify for detecting the epochs. One is from linear prediction analysis. Madam, these two participants are electronics and communication background or computer science
Yes,
background?
sir, we have a mixed type of participants, sir. We both electronics also and CS also, sir. You can
Uh,
go ahead.
Roughly, how many participants are there?
Sir, around 50,
Okay,
50 from electronics. I guess that approximately.
out of that, how many are from computer science?
Sir, among 100, 50 equal, sir. 50 and order from computer science, 50 from EC background.
Okay. These computer science students may participants. Okay. These are faculties, I think, right?
Sir, both, sir, faculties and research scholars in speech signal processing also.
Okay, good. Computer science background people may feel a little bit uncomfortable, but over a period of time, they may get hold on to some of the terminologies. And anyway, there are different methods for identifying the epochs. Epoch extraction from linear prediction. Linear prediction is a good old method to analyze the speech. What is done in the linear prediction is that present sample is predicted from past samples. And when project sample is predicted from past samples, the thing, see, prediction may not be 100% correct. Then what I will do is I have predicted signal and I have the actual signal. Then difference is the error. When you have this predicted and the actual signal, when you find the difference, out is the error. See, where error occurs is that see, the way LP analysis works is present sample is predicted from past P samples. LP analysis assumption is fine in the in many cases, whereas for example, my glottal closure starts say closed phase, opening phase, open phase, closing phase. All of a sudden closed phase comes. Therefore, when say vocal fold starts opening reaches to the maximum, that takes for example 4 millisecond, and quickly within 1 millisecond it closes. See, when I'm expecting vocal fold to start opening phase, open phase, it should still keep on opening, but it goes to closing phase and all of a sudden it closes. That's where your LP analysis fails. Meaning of LP analysis fails is that the point where LP analysis fails, there you will get the maximum error because you failed in predicting the present sample from the past samples. That point is the epoch or glottal closure instant. That we are using LP analysis. We are using to look at the epochs. How it works is the following. For example, take the speech signal, and this is based upon LP. See, a segment of voiced speech. Why I am telling voiced speech is in the unvoiced speech there is nothing like epochs because voiced this glottal vibration of the vocal fold is systematic. In case of voiced speech, it is almost closed in the unvoiced speech. Therefore, I am taking a voiced segment of the speech signal from the continuous speech, then perform the LP analysis. That is, from this predict the using LP analysis, you will get like a predicted signal. Then predicted actual minus predicted is the error, and this is the error signal. And you notice in this there are some peaks. These points, those are all reflects where LP analysis is failed, that means maximum error, and those corresponds to the glottal closure instance or epoch. So this is one epoch, this is another epoch. This is make kindly note that nowadays I think many people are little bit studying familiar with the machine learning approaches, neural network. There, one training one iteration is called one epoch, and that epoch and this epoch nowhere related. Then how why that name epoch came in training is there also one cycle, that is once all the training patterns are represented once. Therefore, that epoch is some kind of periodicity information is okay. Now speech signal, perform LP analysis, get the something called predicted signal is S cap of n, actual signal is S of n, S of n minus S cap of n is the error signal, and that error signal is your this one residual. Residual means left out. When you have the LP residual signal, then pictorially you can see this is maximum, but it is very difficult to find peaks because here also there is some maximum. How to find local maximum? And see now all these there see here also there is a glottal closure, but strength of this is different from this. And then sometimes what happens is, in addition to when you are finding the maximum points, you also tend to some points which are not maximum, but significantly they are also for example, here is little bit rather than almost zero of a kind. Now, then when I take the signal to transform this, there is something called Hilbert transformation. Hilbert transformation is nothing but 90-degree phase shifted of the original signal. Perform the do the Hilbert transformation, then whatever you get the signal, this one is called 90-degree phase shifted signal. It is called Hilbert transform or Hilbert envelope of the LP residual. This is your Hilbert envelope. And see now in this case, if you put some threshold, it is easy to look at this. Then what is the difference between Hilbert envelope of the LP residual and envelope of the LP residual? This is the Hilbert transform. This is the LP residual. In what way this is better than this in identifying the epoch locations is that, see, it has having only positive polarity, no negative polarity. It goes 0 to some 1. Whereas here, your error can be positive as well as negative. That's why you are doing Hilbert envelope of the LP residual. Therefore, in this case, it is easy to look at the peaks compared to look at the peaks in the LP residual. Please note the location of the peaks. This is your signal. You got some value, something associated with that speed signal. Here are the values maximum in this case. Where are the maximum are there? They are the location of the glottal closure. See now, you took the speed signal, you did LP analysis, then you took the Hilbert transform, then that Hilbert envelope of the LP residual. Here these are all the peak. Now you may tell what is the guarantee that your method is working? Because see now from this, what is the guarantee? Because assume that you have a reference ECG signal of this, and if you difference that, this is the difference reference difference EGG signal of this. Now if the dip of this difference EGG signal, we know it, the epoch locations matches with the peaks in this signal, in this analysis, then you can say your LP based analysis is working properly to look at the epochs. This is one of the method. See, now LP based analysis to look at the epochs, one method. Then we have different methods. There is something called group delay functions, group delay based approach. What is this group delay approach based is that we perform the Fourier transform, then of the signal, then Fourier transform of the signal. There are complex number, therefore it has both magnitude and phase. Then consider the phase and negative derivative of the phase, that is called group delay function. And using group delay function, another method also, you can find the epoch locations. And that's what, like, it has some advantage. And another method, say algorithm to extract the epochs, extraction is something called DIPSA method, the dynamic programming projected phase slope algorithm. This is a very like old method people used to use. This is the algorithm for extraction, group delay based epoch extraction, and in 2008, one of the like very uh, simple, now appears to be simple in computational complexity is concerned. See, LP based analysis, then DIPSA based analysis are computationally intensive to locate those epoch locations. Tremendous computing, this one is required, computational power. Computing computationally intensive, it takes more time. But one simple approach proposed by, say, from our own lab from IIT Madras, Sri Ramurthy and Professor B. Narayan sir, they came up with the epoch extraction using zero frequency resonator. What that means, the following. Don't worry about this. What are the equation? Zero frequency based analysis means I have a speech signal. I have a speech signal. Pass it through a zero frequency filter. Zero frequency filter means you don't allow any frequency. Allow only the frequency which is having almost zero frequency content, almost zero frequency content, 0 hertz of a can. Then you may ask, why are we doing this? Because we wanted to avoid any vocal tract effect to find the only source information, and almost signal has no frequency content at all, but very small frequency content will be there. That's why it is called zero frequency filter signal. How it works is the following. Now you have a speech signal, perform zero filter, zero frequency, pass it through a zero frequency resonator. That means that resonator or filter allows you to pass the signal just zero frequency hertz of a second. This is the signal that we call ZFF signal, ZFR signal. Now, how are you going to use this to identify the epochs? See now, take this P signal, pass it through zero frequency resonator, then like find the strength of excitation. And this is called ZFF based method. And here I am keeping EGG signal, differential EGG, and I am marking the epochs just to know how this method is working of a kind. And this Hilbert zero frequency filter based method is evaluated using identification rate, miss rate, false alarm rate, and identification accuracy. And you see, this method has performed well, zero frequency based method for location of the epochs. What is the meaning of identification rate 99.04% means that when, let us say, I will speak a sentence, and let us say it takes some 3 seconds. Then for every second, for every 5 millisecond, my glottal closure vibration closes once. Therefore, in 1 second, 200 times. In 3 seconds, I am expecting 600 times it has closed. That means I have to find about 600 epoch locations in the sentence, and almost say 90% of the epochs are identified properly in Hilbert and Muller base, 92% is group relay base, 96% in DIPSA, and zero frequency based method 99% of the time. That means out of 600 epochs, it's supposed to find maybe it has found about 594, 95 of a kind. That is the meaning of this. Why it has done well, zero frequency based method compared to other method is that one thing is simple, therefore things may not go bad, and not many parameters need to be tuned. And another thing is you are blocking all the frequency contents almost by passing the signal through zero frequency resonator. That means vocal tract effect is not at all there in the what you call the processor speech signal. After passing through the signal, after passing the speech signal through the what you call the zero frequency resonator, just what you get is almost sine wave of a kind. See, for example, almost sine wave, and strength of excitation you obtain this. Those are all the glottal instances. Peaks, these are all mapping with the reference glottal closure or epochs in case of EGG signal. This is the thing about one of the method called zero frequency filter based method. And this method has been various methods are evaluated with respect to different you may tell if it's the clear signal how it works, if it is the noisy signal how it works, a noisy signal of various signal to noise ratios how it works, and different kinds of noises also how methods are working. For example, when I have a white noise, signal to noise ratio is 20, 15, 10. How various methods are worked. Say I have a white noise, signal to noise ratio is 20, Hilbert envelope 84%, group delay 87%, dips are 92%, zero frequency 99%. This is the study. Say when I have a vehicle noise means I am in the vehicle and signal to noise ratio is 10. Then how Hilbert envelope based method, GD based method, DIPSA method, zero frequency based methods are all worked with this one. Okay, now having discussed something about how to find the location of see, these are all points in the speech signal. Epoch means what? Those are the points. What it means? They are the important points. They are like landmarks in the like speech signal. Why you want landmark? For example, if somebody asks you where is SJC, assume that something which is important and near to the SJC, then we will say that is the landmark. We will say it is in front of the Mysore University, or where is some shop, or where is some hotel, or it is in front of the Mysore Palace. This palace is a landmark. For example, if somebody asks you where is All India Institute of Speech and Hearing, or it is in front of SJC, SJC is a landmark. Therefore, that because it has importance. In the same way, in the speech signal, important points, important locations. There are many important locations. Not only like glottal closure, glottal opening is also opening also important. Closing is important. Closure is important. But among them, say closing region, closed region, opening region, say closing point, where starts closing, closed, where exactly closes, opening, where starts opening, open, where reach to the maximum. Among these four, the closing point of the glottis or vocal fold is very important, because when vocal fold totally closes, vocal tract and trachea are disconnected. The point at which that is disconnected, then whatever you are having in the speech signal, that region around that around that closure or epoch, they are assumed to be high P signal to noise ratio signals, high energy signals. Therefore, you are want to perform some of the operations in the speech signal in high energy region. Why high energy region you are preferring? Because that's where speech is there. When low energy is there, it is like noise. That is the reason we are interested in identifying those locations. Then, what are all the possible operations you can do by using those locations, those points? You can detect glottal closure activity. You can perform glottal closure activity using epochs. What it means is, let us say I have a speech signal and different CGG signal and zero filter frequency signal, and from this you can, from ZFF, zero filter frequency signal, what you can do, what is D energy computed over 20 milliseconds. For example, you have the ZFF signal. It has information about the epochs indirectly locations, and for every 20 millisecond, if you take 20 millisecond in this, add the values of those samples, then you plot it, then you will get this. What this represents is, say, wherever this higher values, these are all the point where speech is there. For example, speech is not here, therefore this is zero. Therefore, you can identify in the speech signal wherever speech activity is taking place, wherever the speaker has spoken. We are not interested in what has spoken, wherever the speaker has spoken. See, here he has not spoken, not spoken, not spoken. Therefore, get the speech signal. Use the like epoch information. Then you can get the information about where are all the speech, because you can process sometimes only speech region. We are not interested in non-speech region. Why are not interested in non-speech region? is that it leads to errors when you see, when you perform some operations uniformly across the speech signal, whether it is voiced or unvoiced, or a speech is there or not, then it leads to so many mistakes. Therefore, you identify only the speech regions, do some operation, do some analysis, then it will be more accurate. That's where, like epochs locations, epochs information are very much useful to detect the glottal activity, glot, glottal activity detection, GAD. And glottal activity detection is done on the large data sets, and these are some of the results. You don't worry about that. Now, another application of the epoch is estimation of instantaneous fundamental frequency. Let us say you identify the location, epoch locations, then a particular epoch location where glottal closure occurs. Next location where glottal closure occurs is another epoch. The difference between those two is the fundamental period. Fundamental period means how much time has taken to close this epoch. Again, it reaches to the close phase, and that is very particular to the speaker characteristic. Therefore, instantaneous fundamental frequency. Now I can find the difference between two successive epochs, time location, and inverse of the time is frequency. Therefore, you can, from the fundamental period, say okay, identify the epoch location, find the difference between two successive epoch location difference in terms of samples, then you will convert into milliseconds, and that is reciprocal of that, 1 by that will give the fundamental frequency. Therefore, to estimate the fundamental frequency, we use epoch location. And with non information, like with different noise, all those things, like one has we have done the studies at in the various signal to noise ratio and different noises to identify the glottal closure activities. Next, format frequencies. See, I told, now format frequencies. See, we have the speech. See, what we have is the speech signal. It has information regarding speaker. It has information regarding speech. It has information about the sound units. So when I listen somebody's speech, then it has both who has spoken and what has spoken. That's where, like info, and therefore it has both information regarding source and system. But epoch locations are attributed to the source, and that source information is there in the like speech signal. Therefore, you take the speech signal, identify the epoch locations. Then I said around the epoch location, what happens is a location where glottal closure is there. Then source has no effect on the system. Identify epoch locations and perform. Take some small segment of the speech around the epochs. Then find the formats. That format information is better when you take some small segment of speech around each epoch. This analysis is better than just say taking 20 millisecond, find Fourier transform of that, then put the magnitude plot, peaks in the magnitude plot. That is a magnitude plot is called spectrum. Peaks in the spectrum gives the formats. This is one of the crude method and simple method. Rather than doing that, do one thing. Don't take 20 millisecond, 20 millisecond. Identify the epoch location. Say around this epoch, take some duration. Around next epoch, next. That is it. Then what is happening is in this analysis, you are not doing any block processing. You are not fixing the window of a mole duration. You are taking only high SNR regions. High SNR regions are the regions around the epoch locations. You can find the formats. You may why the formats are required. Formats are required in case of recognizing the speech, or in case of synthesis of the speech, because each sound unit can be attributed by, that is, can be identified uniquely using three formats. Therefore, from the speech signal from small R database have the formats. We want to synthesize the speech, then you use these formats obtained by using very like sophisticated approach. That format analysis, format estimation, epoch location right? And in case of glottal, say I have different kind of sounds, stop sounds. I have are there. I can go here, for example. Yeah, there are different kind of sounds. So unvoiced, unaspirated, unvoiced, aspirated, voiced, unaspirated, voiced, aspirated. Same, and in these cases, what happens is identify the epoch location. For example, this is voicing begins, and before that, frication is there. This is the burst release is there. In case of unvoiced, unreasoned epoch location, see, frication is totally outside this, whereas in unvoiced aspirated frication region and voicing, this one has overlapped, whereas in case of voiced unaspirated is the frication and burst also coming into picture. And in case of voiced aspirated, like the point where like this is the voicing, here is the epoch, here is the epoch, here is the epoch, here is the epoch. Therefore, based upon epoch location and the information about burst frication, you can identify what kind of sound unit it is of, what kind of sound it is of a kind. Okay. And this is the analysis with respect to say different kind of say stop sounds. I have something called in ka, in ka, in ka, in ka. Like these are all the various studies are done with respect to like to identify the different sounds of it. Now coming to what you call characterization of loudness of speech. For example, I am speaking. Whether I am louder than somebody. What is the loudness is measure of what is the strength of a speaker in terms of his speech. In order to identify the loudness, we can use the like epoch information. For example, identify the epochs, then around the epoch locations, like you can find the difference between sample next to the epoch, sample before to the epoch, difference of those things, you can attribute that to the loudness of it. Whether somebody's speech is loud or whether somebody's speech is not that much loud, all those things also can be done by using epoch analysis. And there is something called Lambert effect speech. Say when I am speaking, and assume that I am speaking in a clean environment, then I speak normally. When I speak in a noisy environment, what happens is I feel there is a noise, therefore I should speak loudly. I speak little bit more wisely so that other with more voice, more strength, other speaker can hear. That speech is called Lombard effect speech. It is a normal, not normal speech. To identify Lombard effect speech, epoch locations are very much useful. In what way? For example, I have taken the four speaker, say speaker 1, speaker B, speaker C, speaker D. And what is this this dotted and solid here represents is that say 1 and 2 are female speakers and 3 and 4 are the male speakers. Then here strength of excitation we are plotting. Solid, say broken and solid line. See now this both solid line corresponds to soft and loud speech. Okay, this broken, this represents strength of excitation of soft voice, and this represents strength of excitation of loud utterance. Softly somebody speaks, this is the way strength of excitation. Loudly somebody speaks, this is the strength of excitation. And then normalized frequency, this one. Therefore, you can analyze whether somebody has spoken softly or like loudly by taking speech around the epochs. Analysis is better. Otherwise, if you take the block processing approach, it will be useful. And say, for example, analysis of laugh signal. How are you whether somebody is speaking normally or whether he is speaking by laughing while speaking. For example, this is what you represent, say, contour for the normal speech, and this is Lombard Epoch speech. For an utterance of the sentence, regular attendance is seldom required. For example, like this is normal speech, this is the Lombard effect speech. There is a difference in the normal and this one speech of a kind. See now this see now when somebody is speaking normally, uh, which period for the derived from the epoch, like I said, these are all the what you call which period. Say A is what waveform of the laugher, that is speaking while laughing or laughing while speaking. Then this is the pitch period, and the strength of impulse epochs derived from the zero filter frequency. See now, by observing this, somebody can make out somebody is speaking. You may tell how can you say he is speaking? Ask him to speak normally, then ask him to speak while laughing. Then you can make the differences. Go to the point. And in this way, when you have say processing speech at a distance, it's called distance speech. Close speaking speech and distance speech you can analyze by using like epochs. And how are you going to how in what extent it helps in multi-speaker data? When you look at the there are two speakers, then for example, normally in the say when a single speaker is there, epoch locations are at periodic interval, whereas when two speakers are there, there will be two success, that is periodic intervals will be there, but they are intermixed. Therefore, but you can track them, then you can separate the what you call one from the other. That is this is the way multi-speaker separation takes place. Then what are the applications of the epoch-based analysis? Time delay estimation. You can identify number of speakers in a particular speech. How many speakers are speaking, you can make out from by using analysis. And you can enhance the speech. How are you going to enhance the speech? Take the speech signal around significant of excitation or epoch locations. Take the only part of the speech around that, then perform that. Then you will be what you call enhancing the signal rather than enhancing noise. You are taking only, you are enhancing the signal, you are not enhancing the noise. Therefore, from perception point of view, the enhancer signal will having better quality if you do analyze. And multi-speech multi-channel enhancement, but that is assume that I have collected the speech with by use of a speaker by using various microphones, and I can coherently add the I can individually perform process the individual channel speech, then I can add them coherently. Then that will enhancement will be better. In that case, you are epoch-based analysis is useful. And multi-speaker separation, you want to separate one speaker from the other, you can say for example, because different speakers have different fundamental frequency. In this way, you can use. And practical application system is in the how you are going to use in the speech systems. So for example, if you wanted to do some prosody manipulation, what is meant by prosody manipulation? For example, you want to convert male speaker voice to a female speaker voice. That's called voice conversion. I said that say in case of female speaker, that is fundamental frequency, for example 400, male speaker 200. Therefore, when you assume that male speaker speech is there, identify the epochs, and somehow synthesize the speech by using twice the pitch frequency, then male speaker speech appears like female speaker speech of a kind. The way you can perform the prosody manipulation. Prosody manipulation is very much useful in the speech synthesis, because in case of speech synthesis, we are interested in synthesizing natural speech, synthesizing the speech which is almost natural, that is it is intelligible, that means you can make out the message, and it is natural, it is like it is coming from the human rather than a machine or computer of a kind. In that case, we are interested in intonation, how pitch varies over a period of time, duration, duration of these different sound units, and fundamental frequency. It is a speaker characteristics. These are all very much useful in case of speech synthesis. Therefore, epoch-based analysis is very much useful in case of speech analysis for accurate analysis, and in the normal way of for processing the speech, rather than simply taking the 20 millisecond speech. It has both speech, speaker, voiced, unvoiced, and like a noise, everything's are there, rather than performing any analysis by using standard block propagation method of short term Fourier analysis. If you look at the epochs, analyze the speech with respect to different window sizes and window shapes for a smaller duration, then your analysis will be better and results will be acceptable, rather than performing conventional way of speech processing. I think I have done with the things. Madam, you are able to hear?
Yes,
Hello?
sir. Yes, sir. Yes, sir.
I completed my presentation. Anybody has any questions, they can.
Participants, if you have any questions, sir, paper participants, if you have any doubts, you can ask one or two questions to sir.
And also I will share this paper. They can refer that paper. We have published that paper 10 years back.
Yes, sir. Yes, sir. Sir, I have one question, sir.
Please, madam.
Sir, to enhance the speech signal
Uh,
or to suppress the noise cancellation.
Correct.
Noise cancellation is epoch is the only parameter, sir.
What we are doing is, see, rather than taking 20 milliseconds speed signal at a time and apply whatever confounding or minimum squared error, all those things, I will not take 20 millisecond, next 20 millisecond, next 20 milli, one after the other, and perform the enhancement method. What I will do is, I will locate the epochs, their the location of the glottal closure instance. Then only I will take the speech signal around that. Reason is that is assumed to be high energy signal to energy, signal to noise ratio signal. High SNR regions are the epoch regions. Therefore, I will perform same enhancement technique, but around the epoch location, rather than taking, say, bluntly 20 millisecond at a time, then 20 millisecond at a time, all those things. It is called short segment analysis we are performing by using epochs. With the help of epochs helps us. Just there are the points where you should focus on, rather than taking simply speed signal 20 millisecond at a time, 20 milliseconds. Where to concentrate? Just they will give the yes, that is there. That is the thing.
Sir, could you suggest us for the noise cancellation or sir, noise cancellation and noise reduction is completely possible or both are same, sir?
Listening?
Sir,
Can
is
you repeat?
noise yes, sir. Is noise cancellation and noise reductions are both same concept, sir?
See, their words are little bit confusing. In broader sense, it is same. In which context we are speaking, then sometimes we will say noise reduction, or sometimes we will say noise cancellation. Noise cancellation is usually used in case of what is called communication. Communication, see, not necessarily speech signal.
Okay.
Whereas in case noise reduction, it is in the speech area.
Okay, noise reduction is the terminology I can make use in speech signal processing.
Yeah.
Okay, sir. One more, sir. Two for the noise reduction, other than this filtering techniques and other than any other techniques we are having, sir, can I apply this epoch based calculation for this noise reduction, sir?
Yeah, yeah. See, for example, assume rather than collecting signal by using channel a single microphone, collect using multiple microphones.
Okay.
Estimate the time delay when I have microphones. They are at different locations. Therefore, my speech will reach to different microphone at different instant of time. even in terms of millisecond itself, but they are not exactly reaching to the reaching at the same time, right?
Okay.
Identify the time delay. My say what time is my signal reach to first microphone, second microphone, third microphone. That's called time delay estimation. Then
Mm-hmm.
knowing that I have this much delay in signal in this microphone one, microphone two, microphone three, and so on. Then after identifying the time delay, then what you do is you add these signal arriving at the different microphone coherently. Coherently adding means add simply, then they will not be same. And if you have to subtract the time delay, then if you add them, then it is more, you are getting more evidence than a single channel. For time delay estimation, epoch analysis is useful. But later this coherently adding, we have the different methods.
Okay, sir. Okay, sir. Sir, last one more doubt. Please clarify, sir. Is by noise
Yeah.
reduction, can if we reduce the noise, signal will be enhanced, right, sir?
Yeah, it is like this. See, rather than reducing the noise, try to enhance the signal. Meaning is that you don't bother about the noise, but you strengthen the signal. Like, like where the high energy regions are there in the speech signal. I will strengthen uh, and low energy region is attributed to the noise. I will not touch the low energy region. I will touch only high energy region. That is, I will enhance the high energy region. Therefore, though that initial noise is there, but strength of the speech is increased. Therefore, you will not perceive that noise is there in the signal. This is the meaning of.
Uh, okay, sir. Sir, if I take a research work on noise reduction, then in that, rather than doing the inventions in noise reduction, can we look in the other way? That is enhancement of the signal, and then I can keep the title as noise reduction, sir.
Yeah, you are 100% right. Yes.
Okay, I give the title as noise reduction techniques, but I don't. I'll call the enhancement techniques as a enhancement techniques to be applied for the speech signal, and I
Yeah.
correlate for this enhancement. Reduction? Would it be okay, sir?
Okay, sir. That is true. That is true. That is true, madam.
Okay, sir. Okay, sir. So, yes, sir. So nice to hear from you, sir. Thank you so much. So,
Yes.
participants, we had a great talk where it was an entirely different session for us. So, where reduction, because in the speech, in the history or the literature of the speech, many times you would see that noise cancellations, noise reduction, speech enhancements, all these are there. So now we got a clear picture that when to use reduction, when to use enhancement, and when to use cancellation. So today, sir has told us epoch-based estimations and also what is the speaker separation, multi-speaker separation methods, and also the perception of the enhancement of speech. Everything we could able to listen from him. It was a great talk, sir. So on behalf of the college and from the departments, and also on behalf of the participants, I thank you very much, sir, for accepting our invitation and rendering the very entirely different talk, sir. Thank you so much, sir.
Yeah.
Thank you so much, sir.
Yeah. Thank you, madam. Thank you, one and all. Thanks. I will
Sir,
share the paper and you can share the slides also.
also, yes, sir, please, sir, share your PPT. Sir, right now you share it, sir. Right now, the paper you share it, sir. It is very interesting to know.
No problem. No problem. I'll send. No problem, madam. Thank you, madam.
Yes, yes,
Thank you.
sir. Thank you, sir. Thank you so much, sir. Yes, sir. I request the participants to relog in by 11:20. So we shall have a tea break and come back. And next, we are having a session from Dr. A.G. Ramakrishnan from IAC.